Hello everyone, in this video we will discuss on analysis of toxic chemical in urine sample using solid phase extraction. So let's get started. Every day, people come into contact with invisible toxic chemicals from the food we eat, the plastic bottles we drink from, or the medicines we take. These substances like mycotoxins, bisphenol A, BPA, and drug residues may quietly build up in our bodies and cause health problems like cancer, hormone imbalance, and organ damage. But how can we detect what we cannot see? Urine gives us clues. It is a non-invasive way to check what chemicals have entered the body, but the toxins are often present in very tiny amounts, making detection difficult. This is where SPE comes in. SPE is a method used by scientists to catch and separate these toxic chemicals from urine so they can measure accurately. It helps clean up the sample and concentrate the chemicals, making it easier to study them. In this video, we came up with 3 recent studies. The first study is from RAHMAN et al. 2021, which used online SPE to find mycotoxins in urine from people in Zimbabwe. The result shows that the toxins from moldly food that can be very dangerous. The second study is from Laredo et al. 2025, which developed an automated SPE method to detect BPA, which is a harmful chemical that found in plastic in Brazilian urine samples. The third study is from Cromet et al. 2025, which used a new low-cost micro-SPE method to find drugs and their breakdown products in urine. This method is very useful for forensic and medical testing. All of these studies show how powerful and important SPE methods are in helping us understand chemical exposure. This project focuses on using SPE to detect toxic chemicals in urine and shows how it can help protect human health in a simple, reliable, and efficient way.
Principles of extraction from the 3 journals used are different to each other, since the first journal used dispersive magnetic SPE or the MSPE, then journal 2 used automatic cartridge based SPE, and micro SPE within lab packet column was used in journal 3. First, the journal 1 relies on dispersing magnetic solvent for extraction, which that read directly into the sample to absorb and analyze. Then it magnetically sprayed it without filtrations or centrifugations. Meanwhile, the journal 2 used a pre-packed cartridge or Oasis HLB to selectively retain bisphenol A after enzymatic hydrolysis of urine, then followed by elutions and LC-MS or MS analysis. Next, principle of extraction method in journal 3 used a custom packed column or C18 disc in syringe and a centrifuge to facilitate flow and is achieving miniatures extractions with reduced cost and solvent use. As you can see, those are the comparison between the 3 journal principle, whereas the solvent type used, driving force, target analyzed, elution solvent, and key advantage. In journal 1, the solvent used was magnetic, the analyzed is mycotoxins, and elution solvent were acetonitrile. The key advantages for extraction method of dispersive magnetic SPE is fast and solvent saving. Meanwhile, the extraction of automatic cartridge based SPE used solvent Oasis HLB cartridge, and the target analyte is bisphenol A, which an endocrine disruptor. The elution solvent used a 1-to-1 mixture of methanol and dichloromethane. It is also a fully automated extraction. And the last one is micro SPE within lab packet column, which is used solvent in lab packet C18 disc with centrifugal force as the driving force. Plus, in this case, the target analyzed were 23 drugs and metabolites. The key advantages in this extraction method were low cost and miniaturized.
Next, in analytical chemistry, sample pretreatment refers to the initial handling of the sample before the main preparation or extraction, typically to improve the cleanliness, stability, or detectability of the target analyte. Journal 1, in this study, the author added stable isotope level internal standard directly into the urine sample. After mixing, the sample was centrifuged to remove any particulate matter. This is a classic pretreatment step, which is centrifuge, help to clarify the urine and protect the online SPE system from clogging or contamination. It is also improve the precision and stability of analyte recovery. So although the pretreatment is simple, it plays a critical role in protecting the instrument and improving the data quality. In the second journal, the pretreatment involved a biochemical reaction. Beta-glucuronidase enzyme is added to the urine to break down BPA-glucuronide, a conjugate inactive form of bisphenol A. The mixture is incubated at 37 degrees Celsius for 8 hours with shaking at 500 rpm. This is crucial because BPA is mostly excreted in urine as glucuronide conjugate. Without enzymatic hydrolysis, the analysis would miss a large portion of BPA. This makes it a critical pretreatment to convert BPA to its free detectable form. This pretreatment step ensures that the measurement to reflect total BPA exposure. In the last journal, In this case, the researcher first added a methanolic solution of drug standard into Eppendorf tubes. Then they evaporate the methanol at 45 degrees Celsius using a concentrator, leaving behind a dry residue. After that, urine or water was added onto the dried analyte to stimulate a real sample condition. This is considered as pretreatment as the evaporation step removes methanol, which could interfere with the downstream step. It's prepared the solid analyte mix to interact properly with the urine matrix. This is a physical pretreatment step that ensures the sample uniformity and avoid solvent interfere in the SPE process. In conclusion, the three journals we reviewed use a different but strategic approaches to ensure a better analyte recovery, cleaner extract, and reliable results.
Today, I will share with you about the findings that I get from those three journals, which is followed four standard steps, which is the column conditioning, sample loading, washing, which is the illusion of interferences, and lastly, the illusion of target analytes. In Journal 1, an online SPE system was integrated with UHPLC MSMS for the analysis of 11 urinary mycotoxins. The method followed the four standard steps. Again, as I mentioned before, the first one is the SPE column was mentioned during using aqueous solution with acid and buffer. Then, 100 microliter of urine was loaded at a controlled flow. Interferences were washed away with the same mobile phase, and after 2 minutes, the valve switched to allow backflush illusion of the analytes, which is the target analytes, to the analytical column. This setup minimized manual handling and enabled sensitive high throughput analysis. Meanwhile, in Journal 2, the extraction of bisphenol A was performed using an automated SPE system. After enzymatic hydrolysis, the urine was diluted and loaded onto an HLB cartridge. The conditioning was done with methanol and acetic acid, and the matrix was washed off using aqueous methanol, and BPA was eluted in 2 steps with a methanol dichloromethane mixture. The eluates were then dried, derivatized with densyl chloride, and analyzed via LC-MSMS. And this automated method has improved consistency and reduced labor work. Last but not least, in Journal 3, a micro SPE method was developed using in-lab-packed C18 cartridges. The non-polar column was conditioned first with methanol, and 200 microliter of sample was loaded via centrifugation to allow controlled flow. A variety of solvent combinations were tested for elution, and the best results were achieved with a 40-60 isopropanol acetonitrile mix. This simple miniaturized method required no vacuum system and offered an affordable yet precise approach for multi-drug screening in urine.
I'm Dania and I will speak to you about the summarized result of analysis. The paper talked about an advanced testing method to study the exposure to harmful mycotoxins. Fumonisin B1 was detected in 100% of urine samples, indicates a nearly universal exposure, likely due to the contaminated mix, a sample food. Aflatoxin A was found in 38% of participants, probably because of the cereal, dry food, and coffee. Both toxins are linked to kidney damage and cancer. Aflatoxin M1 and dihydroquinone are present in 80% of the sample, shows exposure to aflatoxin and citrulline, which are associated to liver toxicity and kidney damage. Citrulline itself was found in 40% of the sample, with some levels are high enough to raise health concerns. Zearalenone and exogenate toxin were present in 10% of participants, while its metabolite, alpha-zearalenol, appeared in less than 2%. This revealed that many individuals had multiple mycotoxins in their system. Compared to the traditional dilute and shoot method, the newly developed online SPE UHPLC-MS technique was far more sensitive, detecting toxins at very low levels that older methods cannot. It also can reduce interference and increase the testing efficiency. The second paper revealed that bisphenol A BPA was present in all urine samples collected from 100 individuals. Nearly all samples, 99%, had measurable BPA level with a median of 0.86 nanogram per milliliter. In contrast, BPA was only detected in 47% of hair samples, but with higher median of 4.8 milligram per liter. These differences reflects how urine captures recent exposure, while hair indicates longer-term accumulation. Interestingly, there was no significant correlation between BPA levels in urine and hair, shows that both sample types provide different but complementary into exposure timeline. When scientists estimated how much BPA people were taking in each day based on their urine, everyone was below the old safety limit set by health expert, which was 4 micrograms per kilogram of body weight per day. So, using the old rule, their BPA levels seem safe. But recently, EFSA changed the safety limit and made it much stricter. Now it's 0.2 nanograms per kilogram per day, which is 20,000 times lower than the old one. Based on this new limit, every person in the study had too much BPA levels in their body. They also calculated something called the risk quotient, which is the number that tells us if the amount of BPA someone has is safe or not. If the RQ is less than 1, the risk is low. If the RQ is 1 or more, there is a potential health risk. The study also found that frequent consumption of canned food and beverage significantly increased the urinary BPA levels. Overall, the findings emphasize the need for updated exposure guidelines, so we have a greater public awareness. The third paper talks about the development of micro-SPE combined with UHPLC-MS method for detecting drugs and their metabolites in urine. It demonstrated excellent detection limits LOD between 0.06 and 0.41 nanogram per milliliter, and LOQ between 0.19 and 1.24 nanogram per milliliter. It means that it can identify extremely low levels of substances, which is important in forensics and clinical toxicology, especially when drug concentrations are minimal. The method also showed strong precision with intraday variability ranging from 0.2% to 7.5% and intraday variability from 1.2% to 30.5%, indicating consistent result over the time. The method works well across a wide range of drug levels, so it can accurately detect both small and large amount of drug in urine. It also better for the environment because it uses much less chemicals, over 10 times less than older methods like liquid extraction. This means it creates less waste and is more eco-friendly. Plus, it only needs simple lab tools like a centrifuge, so it's cheaper and easier to use even in basic or low budget.
For the Journal 1, this study successfully developed and validated a novel analytical method that combines online solid phase extraction (SPE) with ultra-high performance liquid chromatography coupled to tandem mass spectrometry for the sensitive detection of 11 significant mycotoxin and their phase 1 metabolites in human urine. The method was designed to address critical challenges in mycotoxin biomonitoring, such as the low concentration of analytes, complex urine matrix, and the need for the high sample throughput. Through careful optimization of extraction and detection parameters, the method achieved picogram levels limit of detection, robust precision, and reliable quantification using a stable isotope dilution. When applied to a set of urine samples from individuals in Zimbabwe, the technique demonstrated superior sensitivity compared to previously used diluted and sheet method, which is DAS, identifying a higher number of positive samples. Overall, this would represent a significant advancement in the field of human biomonitoring by providing a highly sensitive, efficient, and accurate method suitable for large-scale studies. Moving to the second journal, the study was successfully developed and validated a highly sensitive analytical method for measuring the total bisphenol A, which is BPA level in human urine using the automated solid phase extraction (SPE), followed by the derivatization and analysis with liquid chromatography tandem mass spectrometry. The method was tailored to enhance sensitivity, reduce mean label, and ensure consistency across the large sample size, making it ideal for human biomonitoring studies. The assay displayed a strong performance metric with a short analysis time, excellent linearity and precision and accuracy within internationally accepted standard. When applied to urine sample from 100 volunteers in Brazil, BPA was detected in all samples with a median concentration below the health risk threshold. The data suggested that BPA exposure may be linked to the dietary patterns with higher urinary levels associated with canned food consumption. The study not only confirmed the widespread exposure of the population to BPA, but also provide a robust, scalable method for toxicology monitoring in public health assessment. The last journal, this research introduced and validated an innovative miniaturized solid phase extraction method utilizing in lab-packed C18 columns for the efficient, sensitive, and cost-effective extraction of 23 psychoactive drugs, narcotics, and their metabolites from urine samples. Designed with a practical constraint in mind, the method eliminates the need for high-cost commercial categories and specialized instruments by employing a standard laboratory equipment. Through methodical optimization of sorbent mass, sample, and eluent volumes, and also solvent composition, the procedure achieved high recovery rates, low detection and quantification limits, and excellent intra and inter-day precision. Minimal matrix effects were observed for most analytes, and the method displays strong accuracy with relative errors under 5%. Its robustness and reliability makes it a valuable confirmatory tool, and the method also aligns with the principle of wide analytical chemistry (WAC) scoring variable in terms of environmental impact, practical application, and analytical quality. The miniaturized solid phase extraction method has a broad applicability in both clinical toxicology and forensic science, offering an accessible and sustainable alternative for comprehensive drug analysis in a biological samples.